Hello students, I am coming for one new class of electric field. Actually in a last class we discussed electric field lines. The concept of electric field lines will lead us to one very simple way to calculate electric field in case of complicated or big size object. How I am coming to it one by one. Before that, one other definition we should discuss. Here we discuss one definition of the electric field. It is electric lines of force or electric field lines. The other definition is electric flux. Electric flux. You write the definition first, right? It is defined as the total number of electric lines of force. It is defined as the total number of electric lines of force passing normally through an area. Okay, let me explain. Say for example, these are electric field lines. I am drawing uniform lines, may not be uniform. Clear? I am just drawing one simple situation. So this is electric field lines. Yeah, if you place one area here like this, then lines of force passing perpendicular to it. But in the same area, if you place in the same electric field, say like this, then all the lines of force passing parallelly, none is passing perpendicular or normal to it. So in this case, flux is 0. Flux symbolically shown by the letter phi. So in this case flux is 0 because no lines of force passing normal to the area. Here lines of force passing normal to the area. Here if passing normal to the area, then only it can contribute to flux. Now exactly how this flux helps us in doing our calculation, I am coming to it. First of all, we must know what is flux. So flux by definition already written. So how to do a mathematical how to identify one mathematical equation for flux. Here I am drawing electric field as field lines. So electric field is a vector quantity. Area, this is one surface whose area we should consider. Area of a surface, meaning if you consider, say for example, this surface, it is the area. If you consider a surface, say one object like this, then this is the surface, or maybe this is the surface, or maybe this is the surface, or maybe this is the surface. So in different surface, how to get the surface as a vector quantity, this is important. Yeah? That surface is a vector quantity, and that surface should be always in the outside direction. Meaning, if you consider this surface, clear, the direction of this surface is perpendicularly outside. Why I am coming to it, just wait. Clear? If you consider say one ball like structure, surface for this portion is perpendicularly outside, surface for this portion also perpendicularly outside, surface for this portion also perpendicularly outside. Actually why it is so, that is coming from that idea. An area, any area, if you consider an area, you can observe only from the perpendicular direction. Just look at, I am giving one example. Say look at my hand. Clear? This is the area. If someone observe perpendicularly, then he can see the full area. Clear? If someone observing it, say for example like this, clear, he can see a line like that. It is not area. Clear? If you want to observe this area, you must observe perpendicularly. So you can say it is present only in that perpendicular direction. Is that clear? Okay. So if you consider area of this portion as S vector, an electric field like this, flux by definition is E dot S. Why E dot S? Just let me explain. Look at this case. Here also electric field in the same direction. Area for this portion like this, because area we should draw perpendicular to the surface. So in this case, electric field and area makes an angle 0 degree. Makes an angle 90 degree. Electric field in this side and area like this makes an angle 90 degree. If you write dot product of two vector making an angle 90 degrees 0. So in this case flux is 0. Actually flux 0, that is adjusted in the formula. In this case E and S in the same side, so angle between them is 0 degree, so we will get maximum flux. So drawing shows here maximum flux, here minimum flux. So flux by definition is given by E dot S, and that E dot S comes from observation. Now this is the definition if the field is uniform in the whole area. You may have a situation, say for example, one area considered where everywhere electric field is not same. Say for example, I am considering one area like this. It may be of any shape size, electric field here or electric field here or electric field here or electric field acting here not same. Clear? Then we cannot do calculation for the whole area. We should do in a different way. So I am going to write it first. You write how to calculate flux, already definition of flux written, right? If in a uniform electric field E, you should put a vector sign over E. If in a uniform electric field E, a vector sign required, an area S, over S you have to put a vector sign, then the electric flux associated with the area due to the electric field is given by, you write this equation. This is the equation. Clear? Then you write separately. If throughout the area electric field is non-uniform, meaning everywhere same electric field is not there. If throughout the area electric field is non-uniform, in bracket not the same, then electric flux associated with a small area ds. Then electric flux associated with a small area ds. In that case we cannot calculate for the whole area. In a small area ds, meaning in that case we have to consider a small area here. Say this area is say S vector, some electric field present say E vector. The electric flux associated with a small area ds, I am drawing this ds separately. Say this is my ds vector and some electric field acting like this. Say angle between them something theta. The flux associated is given by E dot ds. The flux associated is given by E dot ds. So if you want to find total flux, of course integration of E dot ds. How to do integration, that I am going to discuss. So be careful how to proceed. If throughout the area same electric field, just go for E dot S. If throughout the area electric field is not same, then consider a suitable small portion and use the formula E dot ds. You have to integrate depending on the variable present. So what is electric flux? The definition discuss. How to use this concept of electric field? For that I want to show two simple problem. One with uniform electric field and one with non-uniform electric field. I hope no difficulty in that. Okay, write the question first. Right. A uniform electric field E is equal to 2I cap minus 3J cap minus say plus 5K cap 5K cap 2I cap minus 3J cap plus 5K cap exists in a region. 2I cap minus 3J cap plus 5K cap exists in a region. Find electric flux associated with. Find electric flux associated with a cube. Find electric flux associated with a cube bounded by the surface x equal to L, comma x equal to twice L, y equal to twice L, comma y equal to thrice L, z equal to 0, comma z equal to L. Find electric flux associated with a cube bounded by the planes x equal to L, x equal to twice L, y equal to twice L, y equal to thrice L, z equal to 0, z equal to L. You know any cube carries 6 surfaces. So all these surfaces available. Just let me draw for you once. Clear? Drawing is important to visualize the whole thing. Look at the cube starts from x equal to L. So not starting from x equal to 0, starting from x equal to L. And the cube ends at x equal to twice L. So the cube ending here, x equal to twice L. So it present from x equal to L to twice L. But not present from y equal to 0, present from y equal to twice L here. It is present up to y equal to thrice L. So the base of the cube, we get it like this. We got it like this. Then z equal to 0 meaning xy plane is one surface, the other surface is z equal to L. Z axis is in this side, so length of the cube is available. Length of the cube is L and the cube placed like this. All the planes accordingly drawn. Clear? I hope no difficulty in that. Okay, we have to find total flux. In any cube, 6 surface present. Clear? All these 6 surface we should consider. Clear? If you consider the first surface, I am considering this surface. This surface. This surface area should be in outside direction. If you consider this surface, then area should be towards right. If you understand these two properly, remaining automatically comes out. Let me calculate flux on the first surface. First surface meaning I am considering extreme left surface, meaning this one. Flux is given by E dot S. Why E dot S? Because electric field uniform. Here no x-axis, no y-axis or z component present. So along x, along y and z, it is not variable, fixed. What is E? This value, whatever E you have to write. Area for this surface, you know, side of the cube is L. So the surface we are considering is like a square. So area is L square but minus I cap. We know in case of dot product, z dot I, z dot k, these are not required. I dot I is important. Clear? So here these two terms will give us 0. If you put the value here, you will get minus 2L square. So flux on the first surface comes out minus. I hope no difficulty in that. Okay. If you look at the second surface, this is my second surface, this one. Area here on the second surface I am drawing by S2 vector. So flux on the second surface, if you write, it is also given by E dot S formula. Same E you should write. Area in this side, so it is L square J cap. Where L square I cap. I cap meaning along x-axis. Previously minus I cap meaning opposite of x-axis. Clear? So if you put the value, clear? Same E, J dot I and J dot I or K dot I is not important, only I dot I important. It is twice L square. I hope no difficulty in that. Okay. I am calculating now flux in the third surface. Third surface meaning y equal to twice L, meaning I am looking at this bottom surface, this one, that bottom one. Area will be in downward direction. Clear? So electric field, the same electric field, whatever available here, you should write. Area for this surface is L square in the downward direction, so minus of J cap. Area of this surface in downward direction. Area you should always write perpendicularly outside. Previously from the first surface, area perpendicularly left. For the right surface, perpendicularly right. For the bottom surface we are writing, so perpendicularly bottom, always outside. Area always present outside the object, perpendicularly. Flux on the third surface I am writing. If you write same, clear, J dot J is important. So it will be, after putting, I am just not putting the value you have to do. It is 3L square. Flux on the fourth surface I want to measure. Fourth surface meaning that y equal to thrice L, meaning the top surface. Yeah. On this surface, area will be in outside direction. Clear? In that case, same E you should write dot L square, outside surface is J cap. In that way, if you put the value, it will be minus 3L square. In exam, you may get question of flux in each surface or total flux also. In my question, we have to find total flux. So I am showing each and every surface separately. Now the fifth surface. Fifth surface meaning z equal to 0. Z equal to 0 actually the backside surface, meaning the surface of this paper. Clear? Area will be in that side opposite of z axis. So same E you should write, dot area of that one L square in minus k cap direction, because this side z axis opposite of that is minus of z axis, meaning minus k cap. If you write only k cap important, so minus of 5 L square. Similarly, flux of the sixth surface, meaning the front one, if you write the front one, the perpendicular will be in this side like that. So in the same way, if you put the value, it will be 5 L square. So in this case, all the surfaces we are calculating individually. Luckily, if you go for their sum, total flux will come out 0. It is not that 0 always. In this case, luckily it comes out 0. This is the first problem, so I have adjusted the values there. I have no difficulty in this way how to calculate flux. This is uniform electric field. Let me show one question of non-uniform electric field also. Clear? One question of non-uniform electric field with the same idea. I'm sure you can do it now quickly. Electric field. Now for the second question, I'm writing first question done. I want to make electric field non-conducting. Say for example, twice x I cap plus say 3y j cap plus say plus or minus, say I'm writing last one minus. Any plus or minus immaterial. I'm just interested in showing what to do. Say for example 5 z k cap. So in this case here the field depends on x, y and z, so it is variable. Clear? Write the question first. Right. An electric field is given by the equation, you write this one. An electric field is given by the equation, you write this one. Find electric flux. Find electric flux associated with a cube bounded by the planes. Associated with a cube bounded by the planes. Bounded by the planes. I am writing slightly different plane, any plane possible. X equal to 0, x equal to L, y equal to L, y equal to twice L. Last one, z equal to 0, z equal to L. Clear? The question over, we have to find flux. Let me draw first. This is x axis, this one y axis, this one z axis. In this case, it starts from x equal to 0, so it starts from this to x equal to L. So the cube is present from x equal to 0 to x equal to L. But it is not starting from y equal to 0, starting from y equal to L here to y equal to twice L here. Meaning the cube is present here. From x equal to 0, this is x equal to 0 to x equal to L. But not from y equal to 0, from y equal to L to y equal to twice L. Z equal to 0 is this plane, z equal to L meaning this one. I am drawing this figure slightly bigger in size. Here also each side of the cube is L. So here also 6 surfaces present, one left side, one right side, one bottom side, one top side, one back side, one front side. Clear? Flux on the first surface I want to measure. Flux surface meaning x equal to 0, meaning this one. If you look at this surface, clear? This surface, if you consider, meaning this one, area will be in this side, towards left. Clear? As area towards left, factor for this area is L square minus I cap. As minus I cap, J cap and K cap will go cancel. So I am writing electric field dot area. These two not going to contribute, so I am not going to consider. Electric field is twice x I cap dot area is L square minus I cap. If you consider the first surface is x equal to 0. So this x equal to 0, so flux on the first surface is 0. I hope clear. Flux on the second surface I want to measure. Second surface meaning x equal to L. So this surface. On this surface area like this S2. So area will be here L square I cap. If as I cap present flux comes from dot product J and K, will give us 0. So electric field with the second surface, I want to do dot product. After you put the value, j and k goes cancel, it is twice x L square. In this surface, what is x? L. So it becomes twice L into L square. So it is twice L cube. This is the flux of the second surface. I hope clear. Flux in the third surface I want to measure. Third surface meaning this bottom surface for me. In this bottom surface, area downward. So whatever electric field will write, area will be L square in minus j cap direction. As j, only j of the electric field gives the answer, k and I 0, because dot product of mix up of product is 0, only I dot I, j dot j or k dot k important. So here I dot j no need to write, k dot j also no need to write, j dot j important. So it is 3y j cap dot L square minus j cap. Clear? It is minus 3y L square. What is y? In this whole surface, y is L. If you put minus 3 L cube. I have no difficulty in that. Flux in the fourth surface I am going to write. Flux in the fourth surface when you write, it is E dot L square j cap. Fourth surface meaning in the question, first, second, third, fourth. X equal to twice L meaning I am looking at this surface. On this surface, area will be in outward direction. From here outward. So that is why j cap along y axis. If you write, it is 3y L square j cap. But y for that surface, y for this second surface is twice L. Be careful. 3y is twice L into L square. This j cap, j dot j goes cancel. So it is 6 L cube. There, flux on the fifth surface is z equal to 0. It is E dot last backside surface is facing backside, so it is L square in minus k cap direction. If you write E k cap, I cap goes cancel, no need to write, j cap also goes cancel, no need to write, this k cap is important, k dot k, so it becomes minus of 5z L square. But on this surface z equal to 0, so this answer also 0 because z 0. The last surface, flux on the sixth surface, it is E dot L square k cap, because the last surface meaning the front surface. If you consider the front surface meaning this one, area is in front side direction. So in that way, if you put the value, E is after doing product minus of 5z L square. In this surface, z equal to what? Written the question L. So z equal to L, if you write, it is minus of 5 L cube. So here, in some surface flux present, in some surface flux is 0. You may get question like this, identify the surface where flux is 0. Identify the surface where flux is positive. Identify the surface where flux is negative. That kind of question also possible. My question is total flux. So my advice is total flux meaning go for sum of all this. All this flux as separately calculated, their sum gives us the total flux. So I am showing you how to handle in case of cubical object. It is not that always cubical object, then how to handle, that will be my next question. Okay.